Now we're kind of on this, and we've talked about various test methods that we can use for various things. Are there any tips and tricks that kind of help expedite this for anybody? And we all met at Power Test, and that was one of the things that you two did, which we're changing out tips and tricks on various pieces of test equipment. And so, are there any good ones that will help folks out in the field with this? There you go.
I got one. Greg, can you pull up that 4-point tester that you got right there?
Yep.
Hey, everyone, look in the lid.
Yeah.
Diagram of how to
exactly.
use it.
There's a diagram. And this diagram covers the majority of your uses too. Doesn't cover everyone, but it covers pretty much everything you're going to do.
I'm gonna go old school dad on some people and be like, you know what? Like when you went to take your driver's test, what'd you have to do? You had to read the manual, right? Most people did. They had to read the manual, so it doesn't hurt to sit there and read the manual a little bit. Another real quick tip I'll say, because Gregg had mentioned it about the frequency and being isolated, is that most of these test sets have like a light, or like this one right here will flash up like a dash 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 when it's got like some kind of an error. Usually that is, it's some kind of interference with the test set. So it recognizes that there's other signals present, and it's like, I can't make a proper measurement for you. Mm-hmm. And so quite often, along with reading those manuals, understanding what that means, if you see that little light coming on saying interference and you write the number down anyways, that is you as a test technician just not knowing how to do your job.
Yep.
What are some of the things that cause the interference there?
So exactly what Gregg said earlier, right? It could be your what if you're doing step and touch potential, sure, and your grid's still on, like your substation's still running. Like I mean, you have 60 hertz all around you, and you're trying to do step and touch potential at 60 hertz. So some test sets will run off frequency at 59 or 65, or mine's like 1080 here, and his is 2000. Like they'll run off frequency, but they might still get some kind of transient switching spikes or any other kind of interference that might be in the area. If you're at processing plants and it's an indoor sub and you're trying to check the grounding system there or something like that, there's a lot of stray signals that go on. So just
like motor what would be like in a manufacturing scenario? What are some of the things that you would see that would cause that? Are you getting like, it's just improper bonding, or are you seeing the transients on the test equipment? Okay.
Yeah, a lot of stuff like that. Anything that really chops up your signal, that can have an effect on. But the thing is like like Gregg said, if you isolate, you should never have that problem. You do a proper isolation, and you know what your test setup is, and you try to make sure that it's set up for that. This should be like a one-off scenario that you run into once in a while, and then that light comes on or the dash 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 comes up. That's a notification to the operator saying, "Hey, double check your stuff."
That's right. What I was going to ask. That's definitely a leading edge indicator that, hey, you didn't properly isolate what you need to, and
it's
have to go revisit type thing.
I mean, these manufacturers know that there are limitations to their test sets, so they try to help people in identifying those limitations. And if you just don't use the tools to their maximum extent, then you're doing yourself a disservice at the same time.
And I know that one of the things that we kind of harped on in several of our prior conversations, Tom, this one's geared towards you, is like pre-operability checks and making sure. Are there calibratory methods that come into zeroizing and all that other good stuff with the various?
So there are, like, Gregg, you can go ahead and power your one up, and I'm going to turn this one on right now. But like I've shown videos in the past on your multimeter. Like you take it, you short your leads together, you grab something else, you measure your lead resistance or a megger. You short it, you open it, you make sure that you get a known reading, right? So this one right here, it's got a light up screen. It's really hard to see that, isn't it?
It'd be rough. You're gonna have to tell us.
Happen. So it says OL right now. I don't know if I can make that dark or not.
I can on mine.
No, that's nice. Gregg's got the new and improved one. So mine says OL right now, so it's basically open line. And then if I go ahead and I put this on here, now it's going to say, and you probably won't be able to read it. It's going to say 5.1, and if you read this right here, it says on it 5.1 ohms. So this is a plus or minus 0.1. So it's a calibration check. Another thing you can do is you can just take a multimeter lead, and I'm going to do this if I can right now with this multimeter, and you put it through and you just short it to itself, right? And then what's your expected resistance of a shorted wire? Zero.
Pretty close,
Yeah, so that's a very easy check that you can go ahead and just put it through, and maybe I can get this to work, and maybe I can't. And 0.046. So it's a very easy check that if you just understand your equipment a little bit. What if I put a shorted jumper in there? Yeah, it's a 0. Yeah, that makes sense. It's just acting like a multimeter at the end of the day, right? I mean, so just treat it like one.
Yeah, your calibration loop is not much different. It's just got a resistor in between it.
Yeah,
that's all it is.
Yeah,
that's all it is.
Yeah, I mean, you can build that. There's nothing fancy about that at all. You could make one yourself with any resistor.
As long as you knew what the base was for the resistance.
Yeah.